red blood cells produced by a single progenitor cell. Image courtesy Hojun Li, Dana-Farber, Boston Children's via Cell Press. Back in the 1950s, doctors began using steroids to treat Diamond-Blackfan anemia, or DBA, a severe condition in which patients cannot make enough red blood cells. There was no real rationale for using steroids, but there was no other good option, aside from regular transfusions. At the time, steroids were being thrown at seemingly everything. But steroids worked in most patients, at least for a time, at the expense of serious side effects such as weight gain, bone loss, hypertension, diabetes and an increased risk of infections. A new study published yesterday in Developmental Cell finally explains why steroids work, and could provide a foothold for developing safer and better treatments for DBA. It could even pave the way to treatments for other types of bone marrow failure. Tracking single blood cells with RNA sequencing. A first clue to how steroids were boosting red blood cells in DBA came in the late 1990s, when researchers gained the ability to grow red blood cell precursors in a dish. In doing so, they found that steroids allowed the precursors to survive in culture outside the body for a long period of time, says Hojun Li, MD, PhD, an attending physician at the Dana-Farber, Boston Children's Cancer and Blood Disorders Center. Steroids extended the duration of their growth. Li. The new study, on which Li is co-first author with Anirudh Natarajan, PhD, for the Whitehead Institute for Biomedical Research, investigated this further by looking at single cells. Using single-cell sorting, Li, Natarajan and colleagues first isolated individual red blood cell precursors from bone marrow. Then, they sequenced each individual cell's RNA before and after exposing them to steroids, specifically glucocorticoids, to see what genes were turning on and off. Keeping progenitors in a youthful state through this technique, they found that steroids were affecting multiple genes in the red cell precursors. Genes that maintain the progenitor state were kept on for a longer time, allowing the progenitors to make more copies of themselves, while genes that push progenitors to differentiate into mature red blood cells were suppressed. What steroids actually did was to put the brakes on how fast the red cells were developing from their precursors, he explains. If you slow down development, you can fit in more cell divisions during the process of making red blood cells, without changing how fast the cells are dividing or how long they survive. The end result is you end up making exponentially more red cells by the time the red cell differentiation process is complete. Slowing down development with glucocorticoids results in many more red blood cells being produced. Adapted from Developmental Cell, steroids effects. Without the steroids, Li now wants to look more closely at the genes affected by steroids, hoping to zero in on one or two that are most instrumental in enhancing red cell production. Earlier seminal work by Vijay Sankaran, MD, PhD at Boston Children's had implicated the GATA1 gene in DBA, but Li notes that GATA1 is involved at an earlier point in blood cell development, responsible for driving more immature, stem-like blood cells down the red cell path. In contrast, steroids seem to be acting later in development, once precursor cells have already committed to making red blood cells. Steroids are a way to make more red cells from the few precursors you've been dealt, says Li. But they have so many terrible side effects. If we can find their genetic right-hand man that acts only in red cells, we might be able to intervene without all the side effects beyond red cells with single-cell RNA sequencing techniques. The researchers could also test the effects of other compounds on the development of red blood cells, and other kinds of blood cells for that matter. With single-cell sequencing, we can see that every cell goes through a continuum of states, from the earliest precursor to the most differentiated cell, says Li. Is there something else we could do to slow the pace of development? If we could apply this principle to white blood cell and platelet lineages, we might be able to help other disorders too. Harvey Lodish, PhD, of the Whitehead Institute, also a member of the Board of Trustees of Boston Children's Hospital, was senior author on the paper. The study was funded by the National Institutes of Health, DKO 6834813, HLO 32262-25, and the American Society of Hematology.